Good morning everyone. Myself Lakshmi Prashanti. I'm a chemistry teacher. Today I'm going to discuss about the molecular orbital diagram of C2 molecule. Molecular orbital diagram of C2 molecule. In my previous videos I already explained the molecular orbital diagrams of hydrogen, helium, lithium and beryllium boron molecules, and in this video I am going to discuss about the molecular orbital diagram of carbon molecule. What we have to know first of all to draw any molecular orbital diagram, first we have to know the atomic number of the particular atom. What is atomic number of carbon? 6. And then we have to write the electronic configuration of that particular atom. 1s2, 2s2 and 2p2. Then represent this electronic configuration in boxes. Okay. S orbital means it is having only one shell. 2s orbital also same, having one shell. But in p orbital it is having 3 shells. That is based on the orientation of the electron. Px, Py, Pz. Here how many electrons we are having? 2 electrons. So 1 electron in 1 shell. After filling all the orbitals equally, then only pairing of the electron takes place. This is based on the principles. How to fill the electrons in atomic orbitals? We have to follow some principles. What are those principles? That we already learned in the first lesson, atomic structure in first year intermediate chemistry. What are those principles means? That is Aufbau principle, Hund's rule and Pauli's exclusion principle, right? So based on that we are filling the electrons in different orbitals. After writing the electronic configuration, we have to draw the molecular orbital diagrams of each orbital individually. Here 1 carbon means 6 electrons, but 2 carbons are combining here to form the molecule C2. So how many electrons? 12 electrons. For 12 electrons we have to draw the molecular orbital diagrams. First for 1s2. This is for 1 carbon and this is for another carbon. What are these? Atomic orbitals. Now these 2 atomic orbitals combines will form molecular orbitals. How many molecular orbitals will be formed? We are having the rule. How many atomic orbitals are combining? That many number of molecular orbitals will be formed. So 2 molecular orbitals will be formed here. How many electrons here? 4. So first here we have to fill 2 electrons. Then coming to the next energy level. This is sigma 1s. How many electrons are present? 2. So sigma 1s square. This is anti-bonding molecular orbital. That's why sigma star 1s square. This is bonding molecular orbital. This is anti-bonding molecular orbital. Okay. Here another thing. Here bonding molecular orbital is present in lower energy shell when compared to its parent atomic orbital. Bonding has to form means it has to lose some energy. That's why always bonding molecular orbitals have less energy when compared to its parent atomic orbitals. When coming to anti-bonding molecular orbital, it is having more energy when compared to its parent atomic orbitals. Okay. Next, for 2s atomic orbital molecular orbital diagrams we have to draw. So this is the 2s2 of 1 carbon. This is 2s2 of another carbon. These are the atomic orbitals. After combining these atomic orbitals, they will form how many molecular orbitals? 2 molecular orbitals will be formed. After filling sigma 2s2, sigma star 2s2. Now what is present left? 2px. Here p means we are having 3 lobes, shells, px, py and pz. In the same way for another carbon, px, py and pz. How many electrons we are having? 2 electrons we are having. Now these 6 atomic orbitals combining to form how many molecular orbitals? 6 molecular orbitals. But here all the 3 orbitals are present in the same energy level. So we can call them as degenerate orbitals. But after combining these atomic orbitals, while forming the molecular orbital, they will be split into 2 energy levels. Okay, 2 energy levels. Firstly pi, then sigma, then pi star, then sigma star. Okay. Here how many electrons we are having? 1, 2, 3, 4. 1, 2. These two are having equal energy. So filling of one electron in each orbital, then pairing of the electrons, pairing of the orbitals takes place. Another 2 more electrons are present. These are paired up. There are no electrons to fill in the pz orbital. This is sigma. These two are pi. These two are pi star. This one is sigma star. Okay. Now write the electronic configuration of the C2 molecule. How can we write the electronic configuration? In the same way, how can we write the electronic configuration of the single carbon atom? In the same way, molecular orbitals. Sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2. Pi 2px is equal to same energy level. That's why we have to put the equal. Pi 2py. How many electrons? 2, 2. 1s is less energy when compared to 1s2. Here 2s is less energy, then sigma star 2s, then pi 2px. These are in same energy level, so 2px, 2py. This is the energy levels, order of the energy levels. In the same way, electronic configuration of the C2 molecule. Increasing order of energy levels. Okay. Now write the bond order. Bond order means half into number of bonding molecular orbitals minus number of anti-bonding molecular orbitals. Bonding means 2 plus 2, 4, 4 plus 2, 6, 6 plus 2, 8. Minus anti-bonding means 2 plus 2, 4. There are no electrons in anti-bonding. So half into 8 minus 4, 4, 2. So between 2 carbon atoms, double bond is present. How can we say it is double bond is present? Based on the bond order. And magnetic nature. How can we explain the magnetic nature? Based on the number of electrons present in all the bonding and anti-bonding molecular orbitals are present in paired condition or unpaired condition. That means singly occupied or doubly occupied. Here all the electrons are present in paired condition. That's why this is diamagnetic in nature. Okay, I think it is clear. Once, see again, first we have to write the atomic number, then electronic configuration. Then for each orbital individually we have to draw the molecular orbital diagrams. Then based on the number of electrons present in the atomic orbitals and molecular orbitals also we have to fill in that way only. But when we come to pi orbital, we have to be careful because splitting of atomic orbital, splitting of molecular orbitals. Okay. Then based on the electrons filled in the molecular orbitals, we can write the order of the energy levels or electronic configuration of the molecule. Then based on the number of electrons present in bonding and anti-bonding, we can easily explain the bond order. Based on the number, after we get the after the calculation, we can say the number of bonds present between the atoms. Then whether the electrons are present in the paired condition or unpaired condition, based on that we can say the magnetic nature of the particular molecule. I think it is clear. Once go through it and once check it. In my next video I will explain another molecule, molecular orbital diagram. Okay. Thank you, one and all.